Let's take the property 4, dot product of equal vectors. What is an equal vector? Assume there is a car traveling in one direction, okay? Another car is the same car, is coming the same direction. So this is the equal vector. Well, at the same speed, if there are two cars hitting, what is the resultant effect? That would be equal, right? So this is square of the same thing. So that's what is given here. So assume there is a vector A dot product with the same vector of its own magnitude and direction. What is a vector? Vector is nothing but magnitude and direction. Resultant force would be double the speed. This is common sense thinking. Okay. Same thing in mathematics. If you apply max on it, what happens? Magnitude of A, magnitude of another the same vector multiplied by cos 0. Cos 0 is 1. Hence, the magnitude, the force is going to be magnitude of A square. That is A square. As a convention, we should remember vector squared, square of the vector is nothing but A vector dot A vector, that is going to be magnitude of A vector the whole square, which can be represented as A vector the whole square, that is equivalent to A square, that is equal to A square. Property 5. It's going to be dot product of unit vectors. What are the unit vectors? I, j, k are unit vectors. We know the dot product of the unit vector equal to 1. I'm going to give you a brief intro about what is a unit vector. We know what is a Cartesian coordinates, numerical coordinates like this. When you mention 2 by 3, this is a rectangular coordinate, two-dimensional system. So here we define it clearly, right? So the point 2, 3 represents the x and y points. This representing the points is called Cartesian coordinate. In a three-dimensional system, like in a room, if you take a corner of a room, you can see it's going to be three things. This is only two dimensions. So you have x and y. Here you would have z axis. So you can have a ball hanging the center of the room, something like that. That has three coordinates: x, y, and z coordinate. Okay. A unit vector is a vector whose length is 1. The length of the unit vector is 1. Often the unit vectors are represented as I, j, k. Right? Since they are unit vectors, they have the cap, but they won't be represented with a hat. Instead, we directly use a vector symbol. Okay, so any ijk vector is a three-dimensional Cartesian coordinate vector, or it can be called the unit vectors codirectional. From the definition of unit vector, this means the magnitude is 1 for I, j, k, and they belong to a three-dimensional Cartesian system. Okay, they represent x, y's, and z. When it is z, unit point is I, j, and k. So the dot product is what? I dot I vector equal to modulus of I vector cos 0. Since it's dot product onto the same thing, it's going to be cos 0. So we know I is magnitude is 1. So this is equal to 1. Same way, replacing I with j, you will get j vector is going to be the same. magnitude of, instead of I, we are going to say j. So since we know it's a unit vector, magnitude, the magnitude is 1, hence the value is going to be 1. So dot product of any unit vector is always 1. It's the inference. That is the multiple property. Second case, we can see the dot product of unit vector of the opposite or perpendicular thing, because we remember I, j and k are 3 different directions, right? So these are all perpendicular to each other. So this and this is 90, this and this is 90, and this 90 degrees, okay? So the dot product of I vector, which is going if you take a 3-dimensional picture, you would find it. Assume, let us take a 3-dimensional picture like this. Let's take a point A in the space. Okay, this point shows the direction, okay, of the point on the box, something like that. This is the point there, okay. This is how the unit vector is going to be. Look at the direction of the OA vector. This is 0 to A. Here is the I, j and k component. If it is going to be a unit vector, it is going to be 1, 1, 1, right? So this will be like this. The magnitude is going to be like this. You can see all the 3 vectors, x, y, z axis in a bar, and the unit vector magnitude is going to be 1, and it is represented in a space. So you can see this thing is represented like this. So it is like the point here. We draw a line, a vector representing this, it will be in a space like this. Okay, so this is how the unit vector, they are perpendicular to each other. Like look, x, y, z are perpendicular to each other. That is the idea. Hence, the unit vector I and j are perpendicular to each other. So cos 90 degrees, when they are perpendicular, then it is going to be 90 degree apart. So cos 90 is 0. So likewise, j and I are perpendicular. J and k are perpendicular, right? So all these 3, anything is perpendicular to the other 2. So they are going to be 90 degree apart, which shows any dot product which is perpendicular to each other is definitely going to be 0. We know these 2 are non-zero unit vectors. When we say unit vectors, the magnitude is 1. So since they are perpendicular to each other, the value is going to be 0. So as a thumb rule, we can remember any 2 vectors of the same sign, like j dot j or I dot I or k dot j is going to be 1. Anything that is going to be not going to have the same notation, like j dot product onto itself is going to be 0. For example, I dot j or I dot k or I dot anything. Okay, but for I dot I, everything else is going to be 0. So by default, you see 2 different things. Remember, the value is going to be 0. Okay, so that is the trick to remember. That is the property 5. So this is the reason explained here. I dot I equal to 1 into 1 into 1. So I dot j is going to be cos 90, 1 into 1 into 0. So that is the property.